Okay. Mm. Okay, collision means when e- any two bodies approaching towards each other, then there will be a of a momentum. And that is okay. So then the collision is any two bodies approaching towards each other, then there will be a redistribution of momentum such a phenomena is called the collisions. Collisions is three types. So two types are another one, then both are basing on third one. So elastic collisions, inelastic collisions. So collision, abhigata collision. Okay, collisions. This is any whenever two bodies approach towards such other, then there will be a distribution. Don't write. Don't write. స్క్రీన్ ఏం పెట్టలేదు, నేను వైట్ బోర్డ్ పెట్టాను మీకు. వైట్ బోర్డ్ షేర్ చేశాను, నాట్ ఎ స్క్రీన్. సో whenever two bodies are approaching towards each other, then there will be a redistributions of momentum. Such phenomena is called the collision. These are three types. So collisions are three types. One is the elastic collisions. Elastic collisions. These are collisions in which both two laws of conservation of momentum and a law of conservation of kinetic energy. So this is apply the kinetic energy, conservation of kinetic energy, and conservation of momentum. These are both are applicable in elastic collisions. That is called the elastic collisions. For example, collisions between fundamental particles. Okay, and another one is inelastic collision. Inelastic collisions. These are the collisions in which only law of conservation of momentum not applicable, and kinetic energy of the conservation of kinetic energy. Okay, only applicable conservation of momentum. This law in that is called the inelastic collisions. For example, collisions between grossy body, that is called the inelastic collisions. Then another one is third one is semi-elastic collisions. Semi-elastic collision. Okay, semi-elastic collisions. There are the collisions in which it is lie in between elastic and inelastic collisions. Okay, this collision in which lie is between elastic and inelastic collisions. So this is the collisions are any two bodies approaching toward each other, then there will be a of momentum, that is called the collisions. The collisions are three types: elastic collisions, inelastic collision, and semi-elastic collision. Inelastic collision and semi-elastic collision. So elastic collision is applicable in conservation of kinetic energy, and conservation of momentum is applicable this elastic collisions. And inelastic collisions is only applying that conservation of momentum, only that law. And third one is a semi-elastic collision. This collision in which the lie in between elastic and inelastic collisions. This is the collision topic. And another one is impact parameter and scattering cross section. What is the impact parameter and scattering cross section? That is, impact parameter means, let us consider one positively charged particle, say I can draw that diagram. See, 1 minute. I can share diagram. See, draw now. So this is one like this one central part of the charge, that is n particle, and n is the particle, and this moves in, this is a this is xy, let us consider xy, then parabolic, see, just wait, so just like that is let us consider g. This is scattering of charge particle by the atomic nucleus gives rise to many Rutherford alpha particles, So let us consider then positively charged particle. Positively charged particle, then that is the direction of x, y. Okay, then that is the positive charge direction, that is the x, y, and this is n. Let us consider that is the n at a point is nucleus. This is nucleus in central part, that is this is the nucleus. If the particle, this is positive charge particle in xy direction, that moves towards the nucleus, there will be a repulsive force between them. Due to this, the particle moves in a hyperbolic path, that is the p a p dash, like this is a hyperbolic path, then p a p dash is repulsive force, then that is particle is moved to, so this is the positive charge particle is uh, this moves towards the nucleus. So this is the one line, perpendicular line, can you draw? And this is a perpendicular line, this is the ny, that is, this is the distance of p. So this ny is called the impact parameter, that is impact parameter. Let us consider one positively charged particle, that is xy. Consider a nucleus particle that moves, this is the particle moves towards the nucleus. There will be a repulsive force then between them, due to this particle moves in a hyperbolic path, that is p a p dash. P a p dash is hyperbolic path followed by this line, straight line path. Okay, so this particle, this is the short distance, that is nucleus and positive charged, that is the perpendicular line. So this is called the impact parameter. This distance is ny is equal to p, that is the impact parameter, that is the symbol of p. Impact parameter is symbol is p. Is also called this is impact parameter, and also called as the collision parameters. It is represented by the, that is p. So this is the impact parameter. So the and another one, and this is this charge particle is directly towards the nucleus, then takes the hyperbolic path along, that is p a p dash. Due to this electrostatic repulsion by the nucleus, this is the electrostatic repulsion by the nucleus, the charge particle, that means comes closest to the nucleus up to then a. So stop the temporarily at point is a, that is called, this distance is called na is equal to b. This is b, this is the distance of b, that is called of distance of closest approach. This is called the closest distance of approach. This is na is equal to b, this is the closest distance of approach. the charge particle is direct towards the nucleus G, takes from the hyperbolic path, that is along with the P dash. Due to this electrostatic repulsion by this nucleus, the charge particle, that is means comes closest to the G, that is N, up to A. Okay, then stop temporarily at a point is A. That this scatter waves, that is the distance of NA is equal to P. That is called the distance of closest approach. That is called the distance of closest approach. And another one, scattering cross section. Scattering cross. This is a closest distance of approach is the symbol of B. Okay, so that is B, closest approach of distance. And another one is scattering cross section. See, I can share screen. Another one is one minute. Just wait. Oh, okay, I can run. See. So, what is the scattering cross section? This is also one of the short answer. Let us consider a material through which that is the nucleus numbers of a particle, including that particle is Dn particle. So then this is the nucleus and this is approaching, then a reflection of this number of waves. So this is the angle of dw, that is the angle of dw. So then let us consider then n is the number of particles incident, then dn particles are coming out of this n particle are scattered. So by the scattering angle is dw, the ratio between the number of that is the number of particles to the total number of particles incidence is called the scattering cross section. Scattering cross section. So this is 1 minute. Scattering cross section. So let us then this is also Rutherford alpha particle scattering experiment also, and the alpha particles of projected into the gold foil, like gold foil, and get scattered in different directions. So let us consider that is n is the incident intensity, the number of incident particle crossing per unit time per unit area of the cross section normal to the incidence direction. So now let us suppose that the scattering, due to the scattering, dn is the number of particles, dn is the number of particles are scattered per unit time in a, that is within angle, that is the, this is the dw, this is the solid angle dw located in a direction making an angle theta, and or a theta plus d theta with the incident directions, and that is the scattering cross section is the symbol of sigma. Sigma scattering cross section. This means scattering cross section. Sorry. Sigma is the symbol of scattering cross section, that is a dn by n. So the scattering cross section is defined the ratio of the number of scattered particles in solid angle per unit times in the incident intensity. Incident intensity. Don't write. So sigma is this is the scattering probability, and that is what is the dn, that is the number of particles or times number of particles within the time. So what is the n? N is the number of particles or area and within the time. So that is the ratio of the number of scattered particles into the solid angle, that is solid angle means dw. dw per unit time in the incident intensity, that is called the scattering cross section. Sigma is equal to dn by, so dn by n. This is the area. Bhargavi. Don't write interest లేకపోతే లీవ్ అయిపోండి, no problem, but don't disturb. So dn by n is the area. So that is called the this is measurement of units of scattering is born. One born is equal to what is the value? That is 10 to the power of minus 28 meter square. This is the scattering cross section. Sigma s is equal to dn by n. So the scattering cross section, what is the definition of the ratio of the number of scattered particles into solid angle, that is dw per unit time to the incident intensity, that is called the scattering cross section. Sigma is equal to dn by n. This is units of scattering cross section. One born is equal to 10 to the power of minus 28 meter square. This is the impact parameter and distance of closest approach, and scattering cross section. This is also important questions. And collisions is the three types: elastic collision, inelastic collision, semi-elastic collisions. This is what is the impact parameter is the charge particles and nucleus, that is the distance of perpendicular, draw a perpendicular line, that is the distance of ny, that is equal to p, that is the distance of this, that is called the impact parameter. And that is this particle is approaching in nucleus, then that is the towards the moves in reflection, that is repulsion, then create a hyperbolic path, that is p dash, then that is the distance of ga, then that is the distance of nucleus na is equal to b, that is the distance of closest approach. Let us consider grn nucleus. This is the distance of na is equal to b, that is called the distance of closest approach. And scattering cross section is sigma is equal to dn by n. This is the ratio of the number of scattered particles into solid angle dw per unit time to the incident intensity, that is called the scattering cross section. This is measured in units of Born, that is scattering cross section. Okay, that is the total impact parameter, distance closest approach, and scattering cross section. And another one, next one, general small definitions can explain. What is the rigid body, and define a rigid body. definition of rigid body is: a rigid body is a solid body and in which the particles are arranged such that there is the distance is small and fixed. That is, the distance between the particles is not disturbed by any external force applied. The particles execute vibrations about their only fixed position. Okay, and what is the rigid body? A body which does not undergo any change in shape or size. That is the then and by the application of external force is called the rigid body. Rigid body, a body which does not undergoes any change, size and shape, shape and size does not change, uh, shape and size, and by application of external force is called the rigid body. So rotational kinetic equation, general rotational kinetic equation, then 1 minute. Rotational kinetic equation, small c. So let us consider this is x-axis and y-axis. This is center rho. Axis is passing through the CO is passing through the axis of the rotation, passing through the O, and this is perpendicular to the axis, and we choose a particle P, and this the coordinating names of position vector is R, that is the angle of theta, and for different particles in the plane, the value R and theta will be different. Okay, so this is one rotational, this is the some space of rotational kinetic equation, and let us consider this is this axis of rotation passing through the O, and this perpendicular to the another, that is z axis, like we choose a particle then P in this, the coordinating namely position vector is R, this is the OP is the distance of R, right? Then and this is the position vector R, and angle is theta. The different particles of this plane, this value of R and theta values will be different. So what is the angular position? Angular position, that is angular position is the theta. This particle P rotates in a circle, rotate in a circle of the radius is R, and theta is increasing an anti-clockwise direction. So theta is increasing in anti-clockwise direction, and it is taken as the positive, whereas theta is clockwise direction is taken as negative value. So that is let s and that is s, that is theta is equal to then surface, that is s by r. This is the s by theta is the angle of theta is equal to s by r. S by r, s be the perpendicular distance, that is the perpendicular distance. So this is theta is equal to s by r. This is the angular position. The particle P is rotating rotated this circle of radius r. Theta is increasing in anti-clockwise direction, and is taken as positive value. Then theta is theta is clockwise direction, then take as negative value. Theta is the clockwise direction, that is the value of negative, and anti-clockwise direction is the positive. So that is theta is equal to s by r. S is between the perpendicular distance. So that is the angular position theta is equal to s by r. And another one, angular velocity. Angular velocity means let the body be rotating in a counterclockwise direction. So let this is x, y, then this, then angle, let us p point. So then the body is rotating clockwise direction. This is clockwise direction at the time t1. This is time t1. Let us consider time t1. The particle is at t1. This while at a time t2, it's at a particle that is p of t2. T2 seconds, that is the time taken t2, then particle is moves, then this is the value of p t2, then angular position, that is the theta 1 angle, and this one is theta 2 angle. This is the r1 position vector and distance also, and then also r2 distance. The angular displacement is theta 2 minus theta 1 is del theta. The angular displacement is equal to delta t is equal. During time interval, what is the time interval? T2 minus T1 is equal to del theta. So the angular speed, that is omega, is equal to del theta by del t. The angular speed is equal to, or angular velocity is equal to omega equal to d theta by del t. So then angular speed, then this is like that delta t, or this is the omega is equal d theta by dt. So like that, anyone. Del means then derivation. So that is this is the angular velocity. Let the body rotating in clockwise direction at the time of t1. The particle is p of t1. So while at t2 time, it is the particle of p2, p of t2. The angular positions of theta 1 and theta 2, and the position vector is p and a point key, that is r1, and another one, this is p1 and this is p2. Like p1 particle is the position vector r1, and another particle r2 position vector. So the angular displacement is theta 1, theta 2 minus theta 1 is equal to del theta, and time interval is t2 minus theta 1. So the angular velocity or speed is equal to del theta by del t. So this is the angular speed instantaneously ఎలా రాసుకోవచ్చు, omega is equal to d theta by dt. What is the angular velocity? Is the units of radius per second, or radius per second, or revolution per second. So that is the angular velocity. And another one is angular acceleration. It is the angular speed, that is omega, of a particle p is a not constant at a time t1, and angular speed is omega, and at the time t2, then angular speed is omega 1 and omega 2. That is this is the variation of angular speed in this time interval, that is t2 minus t1, then give rise to the angular velocity. So angular acceleration like alpha, then omega 2 minus omega 1 by t2 minus t1, that is del omega by del t, or d omega by dt. So this is called the angular acceleration, a or alpha, angular and acceleration. What is the units of angular acceleration? Units are radius per second square. Units means that is radius per second square. That is called the angular acceleration. Angular acceleration means this is angular speed is omega of a particle p is not constant at a time t1, then angular speed is omega, and time t2, then angular speed is omega 2. There then this variation, the angular speed is of a time interval is t2 minus t1, and that is the angular acceleration is equal to omega 2 minus omega 1 by t2 minus t1, that is del omega by del t, and d omega by dt. So this is called the angular acceleration. So this is called the angular acceleration. And another one, equation of motion of a rigid body, that is torque and angular position. Okay, torque and angular movement. So torque is equal to dl by dt. Relation between torque, relation between it is relation between torque and angular momentum. That is angular momentum, L is equal to then the relation between torque and angular momentum, that is torque is angular momentum is equal to L is equal to I omega. And that what is torque? Torque means d. This is the derivation with respect to t. So del L by del t dt. So that is I into d omega by dt. So d omega dt means the angular acceleration, that is I alpha, that is equal to torque is equal to I alpha. Then another one, that is what is this is the sorry, L is equal to I omega, dl by dt is equal to what? Differentiating of I omega. So that is I into d omega by dt is equal to alpha, that is d omega by dt equal to alpha, that is equal to torque. This is I alpha is equal to what? Torque. So dl by dt is equal to what is the, this is the relation between torque and angular momentum. This is torque and angular momentum. And rotational of kinetic equation, that is torque is equal to I alpha. So any axis rotation passing through this center and the perpendicular of perpendicular direction, that is let us consider one particle p, then coordinating position vectors and angle theta అని చెప్తున్నాం. That is simplification of value. Then torque is equal to I alpha. So torque and angular momentum. Torque means that is relation between torque and angular momentum. Equation is torque is equal to dl by dt. And next question, and angular momentum and inertial tensor. And angular momentum and inertial tensor, the axis of rotation does not consider with any of the principle of axis of inertia. The relation between L and omega, that is angular between L and omega is difference from 0, and the motion of can be expressed in this terms of components of angular velocity and angular velocity in the direction of the three axes of the coordination systems, that is which is attached to the rotating body. Then general form of the angular momentum of ith particle, then ith and nth particle ane ith particle is, then general form of angular momentum L is equal to summation of mi into ri into vi. So this is angular velocity. Let us consider then rigid body rotating with the, then one rigid body then rotating with the angular velocity omega or angular speed. About this, then one axis, that is x, y, r, a, b, passing through the point then O. Okay, and every particle in the body will be moves in a circular path around this axis, the center of this axis, and uh, so then see one diagram I can share. See, it is the angular momentum and inertia tensor. Angular, sorry, angular. Angular momentum and inertia tensor. Okay, let us consider that is angular velocity omega at the axis of AB. This is AB axis, and passing through the center of a point that is O. This is O, and every particle in the body will be moves in the circular path, then circular path around the axis, with the center of our axis with the same angular velocity is the omega, and consider it ith particle of the, then ith particle is ith particle of at a point P with the mass is mi, ith particle. Then like ith particle means that is the particle is at P, then mass is mi, and linear velocity is the vi, and that is op, that is the op is the position vector or a radius vector, that is equal to ir, with the reference of that is vi is equal to omega into Ri. So what is P momentum? What is P is equal to mv. What is the V? V is the omega cross R I. So then we'll substitute m into V omega cross R I. So that is m into omega cross R I. Then you know this is the one of the formula, A cross B cross C is equal to A into B dot C, and C into A dot B. This is one of the formula, that is the vector product. So this is the velocity is the V is equal to, then rotating in this direction, that is V is equal to angular velocity, that is the position vector. You know P is equal to mv. Then V is substituting this value. Then this is the simplification of the inertia tensor value. See here another one. See, this is the simplification of angular velocity. So just I can write. See, simply what is the value? L is equal to see, what is L is equal to m into Ri into Vi. You can write now. And another one, that is this is m into Ri. What is the V omega cross Ri? You know. Okay, and this is that is a cross B cross C formula. So m is the constant, that is the summation, like summation, then ith particle, so that is mi. So this is Ri into Ri, that is omega cross, minus and Ri into omega Ri. This is this is the substituting A cross B cross C formula. So Ri into omega minus Ri into omega into Ri. So this is the simplification, that is the value. You can find the inertial tensor, inertia coefficients also. So here that is substituting what is the r and I, sorry, ri and omega. You know what is the value of omega? Omega is the angular moment, angular velocity, that is v omega is equal to I into omega x plus j into omega y plus k into omega z. So what is the position vector? Ri is equal to xi square plus yj square plus zi square. This is I కాబట్టి ఇక్కడ I terms అనేటివి వస్తాయి. So xi square plus yi square plus zi square is the, you can write this ri value and omega value, can substituting that value. See this implication. See here this is omega and ri value, then substituting L is equal to angular momentum is L or J, any symbol. So that is J is this is L is equal to then summation of M into Ri into Ri. So Ri into Ri value can substitute, and omega into Ri value can substitute. Okay, so summation of Mi Ri omega square minus summation of Mi and Xi, that this is the omega dot Ri value can substitute. Okay, so this is L is equal summation of Mi into Mv. So angular momentum L is that is P is equal to Mv, V ante value substitute chestam. So that is L is equal to M into R into I ga consider chesnam. So that is angular momentum J, then whole body, that is J is equal to, you can write Mi into ri into ri omega minus ri, ఇక్కడ దీంట్లో సబ్స్టిట్యూట్ చేస్తున్నాం, దట్ ఈస్ L is equal to Mi ri into ri omega minus ri into omega, that is ri, this is whole. So ri ఇక్కడ ri into omega, this value is substituted in this place. Okay, so then simplification this value, see ఇక్కడ మనం సింప్లిఫికేషన్ చేసినట్లయితే summation of I Mi Ri square omega x minus in this term, that is summation of I M xi, that is xi square, and again plus into minus term, so summation of Mi and xi, that is omega I and omega y. So similarly this term is multiplication in this one, z axis term. So this one. Okay, so then simplification this term. Okay, so this term simplification can write that this is value. ఇక్కడ omega x omega common తీసినట్లయితే మనకి ఇక్కడ term వస్తుంది. So same as this summation is overall summation of ith term means, so that is summation of I is common. So you can write this is the x axis base చేసుకున్నట్లయితే angular momentum అనేది x axis. Similarly y axis, that is y axis means, so let us x axis ఇక్కడ ri minus xi, then y axis means that is ri minus yi squares. So similarly then substitute z axis value. See this method, then you can write directly lx ly, z axis and y axis. So you can write here this value is so ఇక్కడ మనం lx is equal to ixs into omega x. Show this directly can write this is the lx, this x value, you can write this same, similarly same y axis z axis. See this term is, let us consider lx. Okay, this term is summation of Mi into Ri minus xi square is equal to Ixx. This you can write Ixx into omega x. And again this term you can write summation of Mi xi yi, that is Lxy. So Lxy into omega y. So omega y. So similarly, this term also. So we can write this term y. See here xz terms. So Lxz. So like directly L I x z. So you can write I x z into omega z. Similarly, same as this Ly and Lz terms. These three equation you can write. So simply then this is Lx. This term is Ixx, and this term is Ixy, and this term is Ixz. So you can write this is the simply equation. So Ixx omega x plus Ixy omega y plus Izxz omega z. Similarly, y-axis and z-axis. This is the Iyy. So this is the Iyy, and this is Iyx, and this term is Iyz. Same as this manaki z-axis. These three equations we get. So these three equations, no need this one. Okay, no need. This is directly substituting these values. No need this one. Okay, and these three equation you can write matrix method. See, simply this can write matrix method. These three equations. See. So this can write simply. This is matrix Lx, Ly, and Lz. This is Ix, Iy, Iz. This is cross multiplication. These two terms, this cross multiplication, we get three equations. So Ix, Iy, Iz. This is the matrix method of the inertia tensor. So this angular momentum. Angular momentum, that is L is equal to, this term is I, and this term is omega. So L is equal to I omega. L or J, anyone, that is the symbol of I, angular momentum. So L is equal to I omega. What is the I? I is the this term. So I is this term. This is called the inertia tensor. This is inertial tensor equation. This is Ixx, Iyy, Izz, and that is the that is called as inertia tensors. Okay, and this is the inertia tensor values. So the properties of inertia tensor is, it is the same symmetric, and it is for a also sphere, and for a symmetric top, symmetric top is also then properties of the inertia tensor. That is the I is the inertia tensor. Inertia tensor. Okay, this is very important question. This is the angular momentum and inertia tensor is the very important questions, and simplification are inertia tensor I is equal to so that is the angular momentum and inertia tensor. Inertia tensor is equal to, then I is equal to matrix of Ixx, Iyy, Ixx, Ixy, Ixz, and Iyy, Iyx, and Iyy, Iyz, and Izx, and Izy, and Izz. That is the inertia momentum for that is I. I stands for the operator is called as tensor. So that is I is equal to, the angular momentum is equal to angular momentum L is equal to I omega. So simply equal to I omega, and I is equal to I xx, I xy, I xz into I yx, I yy, and I yz, and I zx, I zy, I zz. Don't write Amita. So that is I matrix. That is the inertia tensor. I xx, I xy, I xz, and I yx, I yy, I yz, and I xy, sorry, zx, I zy, I zz. This is called the inertia tensor, and angular momentum L is equal to I omega. This is the angular momentum and inertia tensor value. And this is the basic of motion of one rigid body. Okay, and and another one, next, and rotation of kinetic equation is also, then rotation of kinetic equation, that is simplification, that is the value of uh, then explanation of this, that figure, and angular, then rotational of kinetic equations lo మనం angular momentum, angular position, and angular acceleration and angular velocity is discussed. So that is angular position theta is equal to s by r, angular velocity omega is equal to del t by del t, and angular velocity, that is angular velocity, and angular acceleration is also um, alpha is equal to d omega by dt. This is the basic of rotations of the kinetic equations. And so also equation of motion of a rigid body is, torque is equal to I alpha, and the relation between that is torque and angular momentum, torque is equal to dl by dt. So these are and this is angular momentum and inertia tensor. This is also topics in first and second unit topics. And నెక్స్ట్ క్లాస్లో థర్డ్ అండ్ ఫోర్త్ యూనిట్ డిస్కస్ చేస్తాము. సో వన్స్ యూ చెక్ యువర్ టెక్స్ట్ బుక్, సమ్ పాయింట్స్ that is very important topics these are. Okay, and so thank you, and next class will be continue tomorrow. Thank you everyone. Chart. Okay, thank you.